G'day, my name's Mackenzie, and this is the SIGIR 2022 demo, a common framework for exploring document at a time and score at a time retrieval methods. And this is work done with Andrew Trotman, Parameswaran, and Jimmy Lin. So to start off with, we'll quickly cover a couple of different retrieval methods. So document at a time retrieval essentially uses a document ordered index to find matching documents and to be able to score them efficiently. So in the example here, I've got two postings lists, one for the word buy and one for the word raspberry. And in the yellow boxes, we have a representation of the document identifiers. And in the colored boxes, the green and red, we have payloads. So essentially a document ordered index will store each of these lists in ascending order of the identifier. So here you can see buy has document 2, document 4, document 5, document 6, so on. And these numbers will always be increasing. And so what that allows you to do is efficient document at a time retrieval, where you essentially walk through the candidate lists in parallel and make decisions based on the current document you're looking at in each list to find matches and score things. An alternative is score at a time retrieval. And to do score at a time retrieval, you need to have an impact ordered index. So before in a document ordered index, we would store a document identifier and a payload or an impact. But instead here in an impact ordered index, we collect all of the identifiers that have the same impact into one single segment. So that exact same set of postings list from before, buy and raspberry, you see that buy here has one set of impacts or one set of documents that have an impact of 3, and that's documents 2, 4, 7, 11, and 12. And then there are another 6 documents with an impact of 1, and the same for raspberry. Now, when you want to do efficient retrieval with score at a time, you essentially visit these segments from high to low order of impact. So you'd first process the 5 impact segment for raspberry, and then the 4, then you'd go and process the 3 for buy, and then you'd process the 1 and the 1. And so these two different modes of retrieval give vastly different trade-offs, for example. And so our contribution in this demo is firstly to take the only existing open source score at a time system, JASS, and we build Python bindings into that system. So we call that PyJASS. We then take PyJASS and we integrate that into the commonly used Pyserini system, which is essentially a Python implementation or a Python interface to the Java-based Pyserini system. And Pyserini uses Lucene to do document at a time retrieval, and it's implemented in Java. And so essentially, what our demo boils down to is the fact that you can take Pyserini and you can either decide to do search with Lucene or you can do search with JASS. And essentially the rest of the API remains unchanged. So you basically can pick which search engine you want to actually process the query under the hood, and everything else remains the same. And what that allows us to do is then do some comparisons. So we ran a couple of comparisons of traditional and learned sparse models. So you have Pyserini and Pyserini and JASS and PyJASS. And essentially we find that, as expected, JASS is much faster than Pyserini because it's a research system and Pyserini is a production ready system. But it also gives us smaller indexes, which is quite useful. And so this framework facilitates comparisons. If you're not interested in doing comparisons, there's also something in it for you. You can essentially accelerate your experimentation as well. Because JASS is much faster than Lucene, if you were to go and run the experiment I just showed above with Lucene, it would take 1,800 seconds. But if you use JASS as the underlying retrieval engine, it would only take about 640 seconds. And so that's essentially what we did. We hope you can go and have a look at the paper, and if you have any questions, please reach out to us. Thanks.